All right. Good afternoon, everybody. My name is Judeson Mondelus. I am from Group 11 from Engineering Design 1. My teammates are Mr. Hedrik, Rahshon, Hugo. We are Group 11. Today, we will be presenting our final project titled AI Assisted Diagnostic and Classification of Dental Condition using panoramic X-ray images. Let me begin with a brief overview of our project. The project description, reading dental X-ray manually can be time consuming and prone to human errors, especially with high patient load or when dealing with early stage conditions that are hard to detect. There's also inconsistency between how different dentists interpret images in many areas. Um, there just aren't enough specialists available to keep up with the demand. The significance of the problem: billions of people around the world are affected by dental condition, but many cases goes undiagnosed due to the limited access to oral care. Um, our AI assisted models is important because it can help address these issues. It's scalable, consistent, provide fast results, unlike human, and it won't affect by fatigue or experience level. If we go to slide 1.3 now, um, the goal and objectives, our goal is to create an end-to-end deep learning system that help dentists detect problem in panoramic dental X-ray. The system will not replace dentists. We have to be clear about that. Instead, it will assist them. Some of our main objectives include curating the database, applying image augmentation, training different deep learning models, designing a user interface, and integrating the entire system for testing and evaluation. Now we're going to move to slide 1.4. Our literature review. We also look at several existing AI systems in dental care. For example, BBUNet has been used for image segmentation. ULOG 5 is known for object detection, and SSAD model has been shown strong performance in dental disease detection. There are also real-world tools like DiagnoCap being used in clinic today. In the next few slides, my teammate will go in more details about the problem with addressing, the design of our solution, and how we plan to build and test it. Thank you.
Hello, my name is Kayque Hedrik, and I'll be going over the proposed design for this project. So, some of the project requirements that we have set up for this project include the functional requirements, which are the system shall ingest and pre-process panoramic X-ray images, detect and classify dental conditions, provide a visual overlay of diagnosis results, allow manual annotation and feedback, display the results in PDF format and findings and confidence levels, and maintain a secure log of each diagnosis session. Some usability requirements include um, the system shall be accessible via a lightweight web interface, and the interface shall display prediction confidence and diagnosis logs. Lastly, we have the safety requirements, which include the system shall not store patient identifying information. Model predictions must include disclaimers for professional view. and all data shall be encrypted to ensure confidentiality and integrity. Now, some of the key parts of our proposed design include inputting the image, and before the model takes the image and uses it properly, it's important that we process the image, which includes changing the file type, the file size, normalizing the image, and making sure that we only have what we want for the model to process. We have to go through a pre-processing unit. After that, once the model is processed, or once the images are processed for the model to use, the model will then conduct image segmentation, which includes dividing the jaw structure from the teeth structure, just dividing the images into easier segments for the model to use. Once the segmentation process is over, the model will then conduct a diagnosis detection. So it will scan the image and detect if there's any missing parts, if there's any conditions in general that the model has been trained to identify. Once those diagnoses have been detected, then the model will then generate an annotation, which it's important to specify that this model is not meant to replace a specialist, but instead to aid the specialist in getting those diagnoses faster and more accurately without like human error. So the annotation process will greatly help the specialist, the dentist, to make sure that the model is getting the right conditions. And even if it does mess up, which it's expected, the accuracy is meant to be high but not perfect. Once those conditions are detected, they'll be annotated, they'll be highlighted to make it easier for the specialist to view. And that'll be part of the specialist verification process. Once the specialist verification process is over, then a log report will be generated to make sure the specialist knows exactly what happened during that session. And in that log report, there will be a security check to see if any safety requirements have been met, which includes encryption of any data used and storage of that data, and making sure that no patient identifying information has been saved. All right, now continuing on to the next slide. These are some of the subsystems that we'll be implementing in this design. And as stated earlier, on the left side are all the requirements. And if you go to a few slides back, you'll be able to see each requirement and a small description of each of them. And in the middle section, you'll be able to see the subsystems, which include image pre-processing, which goes with requirement 1. And that is normalizing the images, resizing, and noise reduction for the AI model to use it with more facility. And then we have segmentation and classification, annotation and visualization, user interaction, annotation and visualization, report generation, session logging, user interface, annotation and visualization, data security and compliance, user interface, and data security and compliance. I'll now be handing this presentation on to Hugo, where he'll be going through the implementation plan.
All right, so my name is Hugo. We're gonna talk about the implementation, the plan, and how we're gonna try to execute this project. The main goal, or what we want to do, is to deliver a cost-effective and accurate, secure IA-assisted dental diagnosis system. Due to HIPAA laws, and since dentists are going to be dealing with a lot of personal information, we want to make sure that we protect and the system and the patients. in a very effective way. So first, we're gonna go ahead and talk about some of the softwares and hardware components that we'll be using. So since I mentioned it's cost effective, we're gonna try to use as many open sources and as many systems that are provided and that are available to us that doesn't require us for us to spend any additional or insufficient money that we don't have to. So the first one we decided to use is Python. Since it's a system that has a lot of flexibility and it's wide adopted by different AI and medical imaging research. It has mature libraries like TensorFlow, PyTorch, and OpenCV that are optimized for image processing and deep learning. TensorFlow and Python, these are industry standard frameworks for building neural networks. TensorFlow offers easy model deployment options, while PyTorch is popular for fast prototyping and research flexibility. Together, as you can see, will give us a large and a better way and agility to become successful with this program. OpenCV and augmentation, which are image processing libraries. It's helpful, it's critical for X-rays since they often have noise. So these are kind of systems that will allow you to separate that noise and make the image a little more clear, and it will help us provide a better and more accurate results. And it'll be a lot better for them to review it. Augmentations provides data augmentations, rotations, flipping, brightness, adjustments. So it'll be to make the image a lot better. And obviously, it'll provide more flexibility as when they're researching and when they are looking for a due diagnosis. React creates a modern, responsive, and user-friendly interface for dental practitioners to upload X-rays, view results, and provide feedback. So this is kind of like a database where they can share information, they can share images within the office, or if they need to send it to different locations. Also, like when you want to get a CD with your images, you'll also be able to use this program to do that. Obviously, cloud GPUs, Google Colab, and AWS EC2. These are training deep learning models require high computational power. So these are like high-tech systems that can be used. There's a free tier Google Colab that we can utilize to try to create an X-ray database that will help you handle large panoramic views and X-rays. AES-256 encryption, which is kind of like a security, as we're dealing with patients' information, we're going to make sure and we're going to ensure that HIPAA compliances are followed, and we're going to have the correct and the proper way to transfer information within desktop to desktop or between the office to the patient. Moving on to the testing and validation. The model testing, each model will be validated using a test set with ground truth labels. Metrics will help us measure accuracy, precision, recall, F1 scores, and confusion matrices. We want to make sure that or ensure that an AI is reliable in detecting cavities, bone loss, root canal infections, and other conditions that will help, as we mentioned, or the main goal is to provide an accurate diagnosis. The pipeline testing, we're going to try to simulate real-world cases from start to finish as follow: image upload, processing, segmentation, classification, annotation overlay, and the outcome will be a PDF report that could be passed on. This by following this flow chart, we guarantee, or we try to guarantee, that no data is going to be lost in the process, and it's going to be a smooth integration between components. The safety testing is to ensure no patient's identifiable data is stored, meaning that if we store x-rays or patient's information, it could be stored, encrypted, and secure.
The development schedule for our dental AI project is structured into 10 focused weeks. For weeks 1 and 2, we will begin data set curation and pre-processing. This will take place by layering the groundwork and collecting, cleansing, and augmenting dental x-ray images. During the next few weeks, 3 through 5, the model development and training will take place. We'll build and evaluate our CNN, and then moving on to weeks 6 and 7, we will have UI development, ensuring that the user interface is best for the professionals on the back end of things, as well as the users on the front end, making sure we have a seamless, easy to use system in place. Going on to weeks 8 and 9, integration and testing will take place. This will include testing the UI system, making sure it's up and running smoothly to our liking, as well as making sure the users who will first test it are satisfied with our UI system. Then we will have the final evaluation and report. This report will lead into us kind of talking about what's best with it, what we could improve later on in the future, and maybe what improvements and things we could change, and kind of go from there and see what's best for our product. Moving on, we have the WBS table, which will display and explain all of the tasks and the description of the tasks that will be taking place over the coming weeks and months, really. So we have certain things that all of our members are responsible for, such as plan structure and and the project preposition into one plan. But certain guys like Hugo focus on budget. Ultimately, we will start this project on July 21st, and we will not end till past early October. So this will kind of be a layout of how we will go about all of these different assignments moving forward. Next, we have the different roles for all of our members. Now, the data and compliance lead, Judeson, handles cleaning and usage for the X-ray data sets, and handles really most of the data work that includes the implementing of AI features, particularly GradCam. Then we have me, where I am the front-end lead, and I develop front-end infrastructure and the interface with focus on usability and accessibility for the users who will be on the front end of these softwares. Then we move on to research and model development lead, which will be doing most of our research for a lot of the different things that we plan on doing to improve our products. This also includes using and finding relevant papers for our product. Infrastructure and delivery lead is Hugo. Hugo collaborates on the front end and back end connectivity and supports model development and hosting, as well as coordinates the final system testing and prepares presentation material. Moving on, we have the budget. Great news, this will not cost anything. The only optional cost that might come into play is the SSD, which would allow for faster software uploads and downloads, and as well as the utilization of just anything related to speeding up the process of our software. We could use a SSD, which would speed up a lot of that development time. So we have a Google Drive, as well as many other options for free cloud services for data, and we would put a lot of our data in there as free storage since it's easily accessible and it does not cost. Moving on, we have our references. These are all the references that we use to get the information provided to you today. And I hope you enjoyed this presentation. Thank you all for all of who were a part of it, as well as all who watched it. Thank you. Have a great day.